to Tennessee's At Home Learning Series for math. Today's lesson is for all fifth graders out there, though all children are welcome to tune in. This lesson is the 10th lesson in our series. My name is Miss Williamson, and I'm a fifth grade teacher in Tennessee schools. Welcome to my virtual classroom. If you didn't see the previous lessons, you can find them at the Tennessee Department of Education website, www.tn.gov/education. You can still tune in today if you would like, but it may be more fun if you go back and watch the other lessons first, as we'll be using previous learning in today's lesson. Today, we'll be learning about adding and subtracting fractions in word problems. Before we get started, to participate fully in the lesson, you will need paper, pencil, and a surface to write on. I'll give you a moment to gather your things. Okay, let's begin. Today we're going to think about adding and subtracting fractions in word problems. A fraction is a number that names the equal parts of a whole. We will also think about how to model our thinking about fractions by drawing models or using a number line. Let's review how to find common denominators. A denominator is the number below the line in a fraction. That tells the number of pieces or equal parts in a whole. I want you to identify the common denominator for these fractions: 2/3 and 1/4. Remember, to identify common denominators, you will want to list the multiples for each denominator. What are some multiples you got for 3? 3, 6, 9, 12, 15, 18, 21, 24. Great job. What are some multiples that you got for 4? 4, 8, 12, 16, 20, 24. Awesome work. Do you notice any multiples that 3 and 4 have in common? That's right. They both have 12s and they share 24. So either of these could be used as our common denominator. Let's try another one. Find a common denominator for 1/3 and 1/8. We already listed some multiples of 3, 3, 6, 9. So let's underneath that list our multiples of 8. What did you get? 8, 16, 24, 32. I'm going to circle these ones in a different color. What is a common multiple that 3 and 8 have in common? That's right. 24 is on both lists. So a common denominator for 24 and for 8 and 3 is 24. Great job. That common denominator for 3 and 4 will help us solve the word problem we're going to do next. Are you ready? Remember, common denominators help us add and subtract fractions with different denominators, which we practiced in previous lessons. We will use this skill to solve a word problem today. Let's look at this first word problem. Alina has a 1-gallon watering can that is full of water. She uses 3/8 gallon to water her roses and 1/3 gallon to water her geraniums. How much water did Alina use to water both the roses and the geraniums? Let's think through this question. What is it asking? It's asking us about Alina's watering her flowers. Well, what information do we know? Okay, we know that Alina has a 1-gallon watering can and it's full of water. Okay, what other information do we know? Well done. We know she uses 3/8 of a gallon to water her roses, And we know she uses 1/3 of a gallon to water her geraniums. Geraniums and roses are just a type of flower. The question is asking how much she uses to water both. What do you think that means, to water both? Do you think we're going to add? Well, let's look. Let's start by drawing a model. Let's draw a model to represent what Alina used to water her roses. So do this with me. Draw yourself a rectangle. Alina used 3/8 gallon to water her roses. So how would I model that? Well, I need to split it into eighths. How do I know? Because my denominator is 8 and it tells me how many parts are in the whole. So let's do that. Take your rectangle and partition it into 8 equal pieces. How many of the 8 did Alina use to water her roses? That's right, 3, because the numerator tells us the number of parts that she used. She used 3 of the 8. So let's shade in how many? 3. Now let's draw a picture to show how much water Alina used to do her geraniums. So Alina used 1/3 gallon of water to do her geraniums. Remember, it's at one bucket, same size bucket. So let's make sure we do the same size rectangle to model the 1/3 gallon. What am I going to do to model her 1/3? Split it into 3. How did we know? Because the denominator tells us we're going to have 3 equal parts. Well done. How many of the 3 parts did Alina use to water the geraniums? Yes, she used 1 of the 3 parts to water her geraniums. Fabulous. We need to combine these amounts together. When we combine, it's like we said before, we're adding. But in order to combine them, we need to have equal size pieces. We do not have equal size pieces right now because there are 2 different denominators. That means we need to find a common denominator. Remember in the beginning when we listed our multiples for 3 and 8? What common denominator did we find? That's right, we said they share the common denominator, 24, which means I can do what to my whole? Yes, I can split it into 24 equal pieces. So 8 times what gives me 24? 3. So to get 24 pieces, each section needs to be cut into, yes, 3. So let's do that. 1, 2, 3. And you may want to go back and check yourself to make sure that you have 24. 3, 6, 9, 12, 15, 18, 21, 24. Fabulous. All right, are we done? No, we're not. But what can I conclude about 3/8? Good, I heard somebody say we can conclude that 3/8 is equivalent to 9/24. Now, remember we're not done because we need to have equal size pieces. So I have to ask myself again, how can I get thirds into 24? Well, what times 3 equals 24? Did I hear you say 8? Fabulous. So now instead of cutting each section into 3, I need to cut each section how many times? Good job, into 8 pieces. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. What conclusion can we draw about 1/3 now? 1/3 is equivalent to what? Good job. 1/3 is equivalent to 8 24ths. Great work. Now that we have the same size pieces, we can combine those. To combine means what? I heard it. Somebody said combine means we are going to add. Fabulous. So I want you to combine those. Give it a try. Fabulous. I saw somebody say I can move these 8 24ths up here. 1, 2, 3, 4, 5, 6, 7, 8 24ths. When I move 8 24ths to combine them, how much water did she use in all? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 24ths. Because 17 out of the 24 pieces are shaded. So Alina used 17 24ths of a gallon. Great work. We can also model this problem using a number line. I want you to draw two number lines, one on top of the other, like so. One of those number lines needs to be partitioned or divided into eighths, and the other needs to be partitioned into thirds. Let's do the top one into eighths. Okay, does your number line look like this? Let's do the bottom one into thirds. Let's start our number line because this is if she used no water. She used 0 gallons of water. This is if she used the entire container or 1 whole gallon of water. We need to do that here as well. 0, 1. Let's make sure, do we have 8 pieces? 1, 2, 3, 4, 5, 6, 7, 8. Yes, we do. And 3, 1, 2, 3. Fabulous. Now starting at 0, I want you to represent 3/8 on your number line. Did you shade in from 0 to 3? Now I want you to start from 0 and I want you to model 1/3. Did you shade in from 0 to the first tick, which would be 1/3? Think about putting the two shaded regions together. Could I move this up here? Are the lines divided into the same number of pieces? No, they are not. How could we divide 8 into the same size parts as we do with the thirds? Remember, we said our common denominator was what? 24. So we're going to do similar to what we did with the bar. We're going to cut each section, each eighth, how many times? 24 divided by 8 is 3. We're going to cut it into 3 equal sections. Let's do that. 2, 3. We should have how many? 24. Now, what size are the parts in the whole now? Yes, if we have 24 pieces, they're each worth 1/24. Now, how many of these are 3/8? 3/8 equals how many 24ths? 3, 6, 9. So could we say that 3/8 is equivalent to 9/24? Now let's do the same thing with our thirds. What do I have to do to the thirds to make them into 24 equal pieces? Did you say cut each third into 8 equal pieces? Great work. Let's do it. 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Fabulous. So what conclusion can I draw about 1/3? 1/3 equals how many 24ths? 8 24ths. Well done. The first shaded part shows us 3/8, or its equivalent fraction 9 24ths. The second shaded portion shows us 1/3, or its equivalent fraction 8 24ths. What would those shaded portions be together? Well, I know that, sorry, getting the right pen. If I need to put them together, I need to add or move forward 8 24ths. 1, 2, 3, 4, 5, 6, 7, 8. If I move forward 8 24ths, where do we move? Where do we end up at? We end up at 17 24ths. So what is an equation we could use to show what we did? Jot that down. Did you say 3/8 plus 1/3, or 9 24ths plus 8 24ths equals 17 24ths? There are some questions that we want to ask ourselves to make sense of word problems. It's always good to ask yourself, what is this question about? What information do I know? And what am I trying to find out? It's always also a good idea to draw a model or use a number line to help you solve addition and subtraction word problems. Now we're going to move on and look at some benchmark fractions. Between which two, I apologize. A benchmark fraction is a common fraction that you can easily compare to other fractions. The number line below shows the location of some benchmark fractions. I want you to look at this number line. These are considered benchmark fractions. Remember, a benchmark fraction is a common fraction that can easily compare to other fractions. So you'll notice these fractions come between 0 and 2. We use these fractions to estimate sums and differences and to check for reasonableness of our answers. Which two benchmark fractions is 1/3 between? Which two benchmark fractions is 1/3 between? How do you know? One-third is between 1/4 and 1/2. Excellent. We know this because they're all unit fractions. That means they have a numerator of 1. And so you can use them, you can order them from least to greatest in reverse order of their denominators. Between which two benchmark fractions is 3/8? Where do you think 3/8 would go on our number line? Well, let's see. We can say that it's between 1/2 and 1/4 as well, because we can get a common denominator. Let's look at these fractions. 1/4. This is in eighths. So let's think about 1/4 in eighths. That would be 2/8. What about 1/2 in eighths? 1/2 would be 4/8. Do you agree? So I know that 3/8 is going to come between 1/4 and 1/2. For low estimation, you're going to use the lower of the two benchmark fractions. So when I estimate, lower estimation would be rounding to 2/8. Higher estimation would be rounding to 4/8 or 1/2. So When you use a lower estimation, you use the lower of the two benchmark fractions. When you use a high estimation, you're using the higher of the two benchmark fractions. So over here on our first one, 1/3, we said 1/3 falls in between 1/4 and 1/2. What would the lower estimation be? Did you say 1/4? Great job. What would the higher be? 1/2. All right. So a low estimation of 1/4 plus 1/4. A low estimation of 1/4 plus 1/4. If I took 1/3 plus 3/8 and I took the low estimation, I would say 1/4 for the 1/3 and 1/4 for the 1/2 to get an estimation of 2/4 or 1/2. A high estimation, instead of using the fourths, I would have used the half. So a high estimation would have been 1/2 plus 1/2 or 1/2. So we can estimate and know that the sum of 1/3 plus 3/8 needs to fall somewhere between 1/2 and 1/2. So if I get an answer that's bigger than 1 or I get an answer that's smaller than a half, I know that that's not reasonable based on my estimation. We can use these estimates to think about if our answer for watering the flower problem is reasonable. Remember, we got the answer 17/24. Does 17/24 fall between 1/2 and 1 on the number line? Well, let's look. Let's go back to our number line we created. Trying to find it. Okay? We said 17/24. So 17/24 fall between 1/2. 1/2 of 24 would be 12. So 3, 6, 9, 12. This would be the half. Does our answer or our sum fall between 1/2 and 1/2? You're right, it does. That means we found a reasonable answer to our problem. Now it's your turn. Try using benchmark fractions on your own. Between which two benchmarks would 5/8 be located? Good job. You said 5/8 would be located between 1/2 and 3/8 because we want to represent those in what? Remember, we want to get a common denominator. So this would be 4/8. 3/4 would be 6/8. So we know 5/8 comes in between 4/8 and 6/8. And so what are some possible answers? Yes, if we use the low estimation, we would say that 4/8 or 1/2. If we were using the high estimation, we would say 6/8 or 3/4. Between what two benchmarks is 5/6? Between what two benchmarks is 5/6? Did you say that it was between 3/4 and a whole? This one's a little bit more difficult. Why? Because I can't change fourths to 6. So when we do our multiples, 4, 8, 12, 6, 12, I notice what common multiple? 12. So let's think about fourths in the form of 12ths. That would be 9 12ths. What about sixths in the form of 12ths? 5 6 would be equivalent to 10 12ths. And what would a whole be in the form of 12ths? 12 12ths. So what benchmark fraction would 10 12ths fall between? You were right. It would fall between 3/4 and 1 whole. Excellent work. Okay. Great work, everybody. Today we practiced adding and subtracting fraction word problems. I hope you're feeling confident about solving word problems with adding and subtracting fractions. You sure did a great job. I will show you the independent practice now, or you can find them in the student practice for this lesson posted on our website at the www.tn.gov/education. Here is the independent practice for today. You did so great today. I'm so proud of you. Good luck on your independent practice and do your best. I hope you know that I've enjoyed being with you today and learning about adding and subtracting fractions in word problems. Thank you for inviting me into your home. I look forward to seeing you in the next lesson in Tennessee's At Home Learning Series. Bye.
You want to hear a construction joke?
Yeah, I love jokes.
Sorry, I'm working on it.
Man. Okay, everyone, for family time today, I have the cards that I had everyone make and write 5 things that they love about the family. And so we're going to take turns and we're going to try to guess who said and wrote what on what card. Okay? Ooh, okay. I'll start. Here we go. We always have a lot of fun eating lunch together on Sundays.
Elise?
You.
Yeah.
Okay. So you wrote this one? Okay.
Yeah.
Who guessed it? Who guessed it?
Me.
Okay. So Amy, you get to go.
Oh, let's do. We sometimes have fun waiting moves together. What? Oh, watching movies together.
Watching movies. Who wrote that? I think
Oh,
Elise
you take
wrote it.
Elise.
Oh,
Yeah.
So who guessed that right? Did we both guess it right?
both did.
Okay, so we each get 2 points. Okay, we'll let Daddy go.
All right. Stir it up here. I love my family, especially when we bake together and then eat what we made.
You.
Yes, that's
Yeah.
me. What, you don't bake with Daddy?
At lunch.